Okay. I'm audible to you?
Yes.
Okay. So, so here there are five phases. These five phases are what? These five phases are define, measure, analyze, improve, and control. Right?
Mm.
Now, after doing this, what we follow roles and responsibilities. That means whenever somebody is working on a project, so who is having what kind of roles and responsibility if there's a project and basis on this Six Sigma methodology, right? Benefit. Why
Mm.
we work on the Six Sigma project and what are the benefits in that, right? And certification. That means what are the certifications values of the Six Sigma that we'll discuss here. Clear? So we are going to the
Right.
next. Yeah. So we say focus on quality. Why we focus on quality? We have discussed. We'll just go through once. So Six Sigma focuses on improving the quality of process by identifying and eliminating defects or error from the system, right? And the goal is what? To reduce
Mm.
the variability and achieve the consistent and predictable results. Predictable results means whatever analysis we are doing on our data, what we have predicted basis on the data analysis, we should reach on the result, right? Data-driven approach is central to Six Sigma is the use of statistical tools only, right? And data analysis to measure and quantify process performance. We each and everything, we do all data analysis. So one system where we are working in that one system, we find out that what actually the problem is. What is the problem?
Mm.
Where is the problem? Right? So what is the problem and where is the problem is dependent on that. Let's say if the problem is of machine, if the problem is in people, if the problem is in technology, if the problem is from customer end, if the problem is from client end, everything that approach, but that all approach will be completely a data driven process. So when we say data driven approach, that means whatever we identify basis on the data. Clear?
Okay.
Now, DMAC methodology. So what is DMAC methodology? What? It is a structured problem solving methodology, right? That we use in Six Sigma. Very structured. First of all, we define it, then we measure it. Define means we define the problem, that what problem we have found. Then we measure, that means data analysis. Then we analyze, and after that, during the analysis, we work on that, and while working on that, we see the improvement, and wherever we have to reach on the predictable results, when we reach on there, we control it, that how to control the problem, and after controlling of the problem, we stop working. Stop working means that the project will be closed. We will not stop working on the methodology, because any methodology of the project, either DMAC or PMP, it says change management. Change is required in the system.
Mm.
Change we are able to find after the project, right? So here we are going to work on the DMAC methodology. So we say here that what is DMAC? What is define, measure, analyze, and improve and control. So we say define. Define is the what? Define the problem or opportunity for improvement. That define means what? Whenever we do the analysis, we define. First of all, we identify. Similarly, same methodology. We identify that what is our problem in our system, right? What is
Mm.
our workable area, right? Six Sigma, we never do, hypothetically on anything. We work which is critical for business, critical to quality, right?
Mm.
If something is critical to quality, you must have heard the word CTQ, critical to quality, then we will work on that and we improve on it. So how do you work on that? So first of all, you find the problem. What is the problem? Why we are
Mm.
unable to perform, right? And then we find the opportunity. That means what are the opportunity area that we can work and improve on, right? And then after that, we set a goal that we where we can reach after working on that, opportunity scope, right? So that is our project goal, right? And that we define as per the customer define and define customer's requirement. That what is customer's requirement? So whatever goal we are defining in our project, will it work in that way or not, right? Now major is what? Major current process performance using the relevant data and metrics. So when we say relevant data, this data should be reliable data. This should not be any other data, right?
mm.
This data
Okay.
should be completely a reliable data, performable data. We can never work on any hypothetical data on this. And the data you are getting from any source, just validate the data by yourself. If the data is correct or not. If data is incorrect, you will not get the correct result. You have
Mm,
to measure the metrics, all the metrics, all the parameters, right? You are in quality, and in quality we use metrics. So you have to measure all the metrics, all the aspects in your system, right? Analyze. Now, how do you analyze? So analyze the data to identify root cause of defects or inefficiencies. So in define, we have defined the problem, and in measure, we have measured the problem, right? What are the problems over there, right? Where we are
mm,
like if there is a continuous fluctuation, or there is somewhere we are very stagnant, somewhere we are going very down, somewhere we are going very high. Why it is not happening? Product quality, service quality, whatever we have found basis on that, right? After that, what you have to do, you have to identify, analyze the uh, root cause of the problem,
mm,
right? What are the root cause of the defects? What are the root cause of the inefficiencies? It is a workable area or non-workable area, right? It is in our control or non-controllable issues. So whenever we identify the root cause, so in the root cause we actually identify if it is a controllable or if it is non-controllable. If it is controllable, we
mm,
control it. If it is not controllable, we cannot control it. But if it is non-controllable, we have to identify the reason why it is not controllable. And if it is non-controllable, what could be the alternate solutions for that, right? This
mm,
is how we analyze that, right? Now improve. Improvement what? So you have analyzed everything. So now you have to, you know that where you have to work, right? So after that, what you do, you improve. Improvements, implement the solutions to address root causes and improve process performance,
mm.
right? So now improvements, we are implementing the solution that these are the problem we have found. These are the errors we have found, right? And basis on those data measurement, we have found this root causes, and we have found this basis on the root causes, we have found this alternate solution to work on, and we have to implement it, right? So implement solutions to address root causes and improve process performance, right? So once you implement it,
Mm.
you reach on the process to improve it. Clear? Once you have
Right.
improved the process performance, what you have to do, you have to control it. How do you control it? So you establish the control to sustain the improvement, right? You have to, during the implementation process only, you have to implement, follow the control process. You remember in PMP, we did the control and monitoring. So when you implement
Mm,
anything, so you have to monitor it regularly, right? And during the monitoring, you have to control also to sustain it. If you do not control, you won't be able to sustain the improvement, right? So, and you have to monitor the process performance also, right? That whenever you have implemented something, you have applied something, is it working or not working? If it is working, what are the good things that is working? What are the things which is not working? And if it is not working, what are the reasons for that, right? Same methodology. And
mm.
basis on that, we control it, right? While controlling the all, errors and all the risk and challenges, what we can do, we can improve on the findings. Clear? So this is
Right.
DMAP: define, measure, analyze, improve, and control. Clear? Shall we move to the
Right.
next one?
Yes.
Okay, next. Now roles and responsibilities in Six Sigma. So we say Six Sigma is actually what it is, a hierarchy of roles and responsibilities, right? We have different designations. Designations was not a post, but yes, designations according to the Six Sigma project's roles and responsibilities, right? That we'll discuss
Okay.
in detail here, right? Now, what is the benefit of the Six Sigma project that you work on? So definitely the purpose of working on a Six Sigma is what? We can lead to various benefit. For example, we reduce the cost. Working on a Six Sigma, there are two main purposes. reducing of cost, increasing the revenue, and improving of quality. That is the main purpose of any product, right? Improved
Hmm.
quality and customer satisfaction. So if quality will improve, so definitely customer satisfaction will improve. Increased
Right.
efficiency, performance, the work performance, efficiency, and competitive advantage in the marketplace. So competitive advantage means what? If there are five other brands and they are doing better than me, so why and how they are able to do that better than me, and what we can do to reach on that. So
Hmm.
that is competitive advantage in the marketplace. That is also basis on the Six Sigma methodology that we do. Clear?
Yeah.
Certifications. What are the six certifications? So certifications, the main certifications. So these certifications not an institution. Actually, these are the regulatory body. There are many third party who conduct the Six Sigma training, but these are the regulatory bodies in the Six Sigma certification. So we say there are
Okay.
several organizations that provide Six Sigma certifications such as ASK and the IASSC, and certification levels include the green belt, black belt, and master black belt, indicating the different level of proficiency and expertise in Six Sigma methodology. Now, if you say about this regulatory, these are the very old regulatory in the Six Sigma. Yes. But yes, any good organization where you go there for the Six Sigma training, which are valid, you can go for that.
Okay.
Yeah. So now Six Sigma principles. What are the principles of Six Sigma? That means rules. The main principle of Six Sigma is what? That, the Six Sigma is applied across all the industries, right? When we say all industry means, manufacturing industry, healthcare, finance, telecommunication, any service industry, even airlines also follow that,
Okay.
right? And the concept and set of methodology of the Six Sigma is to what? First of all, to reduce the defects. If you reduce the defects, the quality of everything will improve automatically, right?
Hmm.
Like for a car, there's a car in the market which has been launched, but the feedback is not good. The sale has been reduced. So what you have to do, you have to
Hmm.
identify the defect in that, right? So whenever
Right.
you identify the defect, you have to reduce the defect, right? You have to minimize the error. Now, there's a difference between defects and error. You understand the difference between defects and error? So
Yeah.
defects
Error
are,
is like a mistake, I guess. Sorry.
yeah, you're right. So defect is like, defect in any product can happen. That is a defect.
Hmm.
Stitching, cutting of the suit is not correct. That is defect, right? Car model, engine quality is not good. That is a defect. Error is what? When, like, the people who are doing some work and they made a mistake, that
Hmm.
work, that is an error, right? Minimizing the variation, there are lots of variation in the system, so we to minimize that variation, increase the quality, increase efficiency. When we say efficiency means productivity efficiency, we have to check why productivity is less, so we have to increase the productivity, that is increase efficiency. Clear? So these
Hmm.
are the methodology and tools that we use to improve the Six Sigma. Now next
Okay.
is what? Six Sigma goal. What is the goal of Six Sigma? So yes, this principle is a goal for the Six Sigma, right? So Six Sigma goal is what? It refers to the target level of process performance or quality that organizations aims to achieve. That is the goal. If the quality of a process is 75%, we have to find the error why the quality is only 75%. Finding the defect, we reach on that 85%. That is our goal. The goal is typically expressed in terms of what? Six Sigma level. How that we'll discuss in tomorrow's session, that how we do that in Six Sigma level calculation. What is 1 to 5 Six Sigma, and what we believe the service industry should be on which level and other industry should be on which level, right?
Okay.
So Six Sigma definition is what? Six Sigma actually corresponds to the number of standard deviations that fit within the specifications and tolerance, right? And that tolerance is calculated in Six Sigma is known as DPMO. Very important. Now, yeah, DPM. There are two terms. One is a DPMO and there is a DPO.
Okay.
DPMO stands for defects per million opportunity.
Defects per million.
Right? And DPO is per opportunity. Defect per opportunity.
Oh, okay.
We'll discuss in detail, and we also learn the calculation that how we calculate the DPMO and DPO. There's a difference
Okay.
between defect and defective, right? So sigma level
Right.
will
Good.
make us to learn this thing. Now, the common Six Sigma level is what? That we have 5 Six Sigma level, but we say that there is Six Sigma, this most well-known level where the process aims to achieve 3.54 defects, which is considered per million opportunity. 3.54 when? Per million opportunity. These are important things that you should know. So you can, if you want, you can make a note of it. So Six
Yeah.
Sigma believes in what? Well-known level is what? That what we believe that how much error you can make, which is acceptable error, that is 3.54 defects per million opportunity. That means 3.54 defects DPMO,
Okay.
right? And this corresponds roughly to defect rate is 3.54 parts per million. That is ppm. This is a
Right.
rate. Corresponding roughly rates, right? Now, we say this is for the service industry, quality industry, right? But if it comes to related to the people life, we cannot take that risk. Even we do not believe in a 3.54 error also. Imagine 3.54 means what? If the accident of airlines increases in that case, that in every per million, we will lose the 3.54 lives. If the hospitals will be careless, in that case, in every 1 million, we will lose 3.54 life. 3.4 lives, not 3.54, 3.4 lives, right? So this is the reason the Six Sigma believes that if we are in the ratio of 3 to 3.5, that we are in average performance and we are doing good, right? And how we calculate the theory of the Six Sigma? That is defect per opportunity is what? Defects per million opportunity, right? Now, how do we calculate that? If we are on 5 Sigma, then how we calculate that opportunity? So we believe at this level, the process aims for no more than 230 defects per million opportunities. This is a simple calculation,
Okay.
right? If it is a, if you are on 5 Sigma, right? So how much error you are allowed to make per million? 230 maximum.
230. Okay.
So if you divide 230 from 1 million, 1 million is what? 10 lakh?
Yeah.
Yes. So if you divide 230 by 10 lakh, what is your opportunity? It is 0.023%, or we can say 23 ppm parts per million, right? These are the important points that you should know. Please make it a, clarity. Now, if you are on 4 Sigma, if your business, your process is on 4 Sigma, then what is the error ratio? Aiming for no more than 6,210 DPMO. That means not more than 6,210 defect per million opportunity, which translates, if you calculate it, it becomes 0.621% or 6210 ppm. Clear?
Right.
Now, if your process is on 3 Sigma, right? If your process is on 3 Sigma, this level targets no more than 66,810 dpm. That means you are on 3 Sigma. That means how much error you can make max to max. That is on 66,810 dpm. That means F We calculate the defect rate. In percentage, it's come as 6.681%. Still, you are able to make that. This is the reason in service industry, in service, we allow 3 sigma. But if it comes to the hospitality industry like airlines and health related, in that case, we directly believe in 5 sigma. We do not allow even on 4 sigma. Because you can check in account 6,210 in every 1 million, right?
Right.
So this is the 3 sigma. So 3 sigma has a maximum error you can defect you can make is what? 66,810 per DPMO. So corresponding, if you calculate it, this becomes 6.681% or the 66,810 ppm parts
Parts
per
per million.
million. This is parts per
Okay.
million. That means there are 10 lakh parts. So out of 10 lakh parts, there is a error in defect in 66,810 parts. That is we call ppm. Clear?
Yeah.
Now we are
So,
coming to,
sorry.
yes,
So,
please, yes.
is 3 sigma, 4 sigma also like viable anymore? Like, does any company or industry have 3 or 4 sigmas?
Yes, that's what I'm saying. Like, airlines, health industries. So no, so 4 sigma for companies will see that which company is working. If some company is working on that sigma, that is definitely on a high level, maybe related to that only, because that's very risky. For that, we'll have to see the list of companies, that which companies are working on that. Yes, companies work on that 4 sigma and 5 sigma also.
I
Reaching
see.
on 4
Okay.
sigma and 5 sigma is very difficult for any organization. If some organization
Mhm.
has reached on the 4 sigma, that's amazing. That's amazing.
Okay.
Yeah. But we do not believe that somebody should reach on the 2 sigma error. If some
Right.
organization which, yeah, if some organization reach on 2 sigma, that means there's a problem. That process is
Okay.
in danger. That business is in danger. They need to work very hard,
Okay.
quickly. Yes.
Got
Important
that.
to work on. Yeah. Clear? That is.
Yeah. Got that.
So we work up to, so making an error is more than 6.681%. That means our process is less than or 3 sigma. Clear?
Mm.
Now we are coming to goals and benefits. We say, what is the goal and benefit? First of all, our goal and benefit is what? To improvement focus, right? We believe that we have to improve,
Right.
right? We have to improve. We have to improve at all, anyhow. Clear?
Yeah.
Now, competitive advantage. Higher sigma levels often lead to lower cost, fewer customer complaint, and increased customer satisfaction and a competitive edge in the marketplace. How will reach on competitive advantage? Very simple. Either your product quality is very good, your service quality is very good, your customer is very satisfied, right?
Mm.
Either the cost is so low, the people like your product, right? Complaints are very less, right? And in that case, you are able to reach the market more, right? That is the competitive advantage. So,
Yeah.
data-driven decision making, whatever decision you are making, that is completely a data-driven approach.
Mm.
That is completely a data-driven approach. Clear? So
Yeah.
Six Sigma, setting and striving for Six Sigma goals requires rigorous data analysis and a focus on statistical
Statistical process control.
process control. And this ensures that improvements are based on objective metrics and measurable results.
Hmm.
Now, Six Sigma represents what? So we say Six Sigma represents the desired, right, level of process performance in terms of defects per million opportunities organization use Six Sigma levels to set quality targets, drive improvement initiatives, and ultimately achieve higher level of operational excellence and customer satisfaction. So whatever we
Hmm.
have learned till now, this is the summary of the Six Sigma, that what it represents. Clear?
Yeah.
Okay. What happened? Mistakenly, actually, while conducting the session, mistakenly I uninstalled my Google Pay.
Hmm. Google what?
Um, I had to transfer, so mistakenly I uninstalled it.
Okay.
Yeah.
Is that on your
Mm.
phone or?
Actually, my mom has gone to hospital. So my brother
Oh,
messaged me
okay.
to transfer the amount to doctor. And this is what I did. Just allow me a moment, please. Done. Okay, sorry for interruption in your session. Okay, now history of
Sure,
Six
sure.
Sigma. We understand how Six Sigma came. In history, we discussed that Six Sigma has a history. So Six Sigma has its own origin in manufacturing and quality management practices, with development and evolution spanning several decades. Has a brief history of Six Sigma. So what are the brief history? So there is, you must have heard this name, early quality management. This is a very well-known name in the market,
Okay.
right? Yeah. So this Six Sigma is well known in EQM is what the concept of statistical quality control began to gain traction or in the early 20th century with pioneers like Walter. We'll discuss about who is Walter, who is Shewhart, who is W. Edwards Deming, because they all were the actual contributor in the Six Sigma,
Okay.
right? Whatever methodology and calculation we'll discuss here, and we'll understand that what is that. It will help us to know that what Six Sigma is and how Six Sigma actually came in the market. That we'll discuss in detail. And ideally, this is
Sure.
the yellow belt basics of the Six Sigma, that everything we discuss here only in the basics with that, right? So they all
Okay.
are known as the father of the Six Sigma.
Hmm.
They all are known as the father of the Six Sigma, right? Okay. So now how Motorola took the initiative. So as we are discussing the history, so how we can leave the Motorola. Motorola is the first who did this, right? So Six
Right.
Sigma as a structured methodology was pioneered by Bill Smith at Motorola in the early 1980s. He was an engineer and he introduced the idea of using statistical methodology to measure the Six Sigma theory,
Mhm.
right? Product quality, to improve the product quality in 1980s, right? And objective was what? To Motorola aimed to achieve the higher level of quality by reducing the defect, right? And they wanted to reach on less than 3.4 defect per million. Actually, this methodology DPMO has come from there. It was Bill Smith who decided
Okay.
that we'll do some statistical calculation, and in that statistical calculation, we believe
Mm.
that our error defect should reach less than 3.4 defects per million. And that
Okay.
defects per million opportunities is like has come as word DPMO, which equates to the Six Sigma level. Clear? So any
Mm.
business, any process, yes, which who is working on less than on 3.4% DPM, sorry, 3.4 DPM, not 3.4% DPM, 3.4 DPMO or less than 3.4 DPMO, that means that project, that business is running good. They are good in providing the services in terms of income, right? That is Six Sigma.
Right.
History from Motorola. Now we learn about the spread to General Electric. The second one was the General Electric, who's initiated it in 1990s. And when they initiated it in 1990s, so the when General Electric, is initiated the Six Sigma project in 1990s. So what it says, the popularization Jack Welch, then CEO of General Electric, adopted Six Sigma in the mid of 1990 as a central part of his
Mm.
business strategy, right? Under what? Under the leadership of what? Wells leadership, right? And GE embraced the Six Sigma to drive improvement in quality and customer satisfaction. This was his purpose, right? That we have to improve the quality and customer satisfaction and operational efficiency also. So this is how this was applicable for all the opportunities that we work, and that's how it works. Now deployment. GE's success with Six Sigma garnered the widespread attention and in leading many other companies to adopt the methodology of their own industries, right? So this became the famous methodology, and after being this famous methodology, the Six Sigma methodology was successful and got applied everywhere, right? This is Six Sigma. Now, when we go to the methodology refinement, so again we have discussed about how we, uh, refine the methodology. So Six Sigma has evolved to incorporate various improvement frameworks, right, and tools. So they believe in the two major theory, which is DMAC and DMAB, DMADB. Now what is DMAC and DMADB? DMAC is define, measure, analyze, improve, and control. Now, what is DMADV? It says define, measure, analyze, design, and verify. So, define, measure, analyze, improve, and control is what? You define something, you measure something, you analyze the root cause, you implement it, and then you control the problem, right? Now, DMADB says what? That you define the problem, then you measure the problem, and then you analyze the root cause. After analyzing the root cause, you design something, right? You design what? A process. After designing a process, you verify that if the process is okay to work or not, right? And
Hmm.
after working on this, you can work on the project and that will be a successful project, right? Now, methodology emerged as a standard approach for process improvement and product development. So whenever you are working on DMAT, DMADB comes automatically in that. That we'll discuss in detail when we will start working on the project, right? Now, industry
Hmm.
applications. What is industry applications? So industry applications are like initially rooted in manufacturing industry, right? Motorola was the manufacturing industry. So purpose of that was to reach the competitive advantage to improve the quality of product was related to manufacturing, right? But when GE came in the market, the purpose of GE was to improve the quality of the product as well as to improve the customer satisfaction also, right? That means in terms
Hmm.
of product and service both. So service comes in quality, right? And product comes in quality. And operational efficiency, that means to improve the efficiency of work, productivity or any other, right? So in that case, what happens, how it applied? So initially rooted in manufacturing, Six Sigma principles expanded to service industries, right? Then applied in healthcare industry, then finance, telecommunication, and beyond. Now it is applicable everywhere. Any big organization, they follow the Six Sigma methodology, right? And its principle of process of is what? Principle of work is what? Data-driven decision making, right? Data-driven decision making is what? Whatever decision you are making, first of all, you will do the data analysis and basis on the data, you will take any approach. You will make any approach, right? You will not make any
Hmm.
approach without the data understanding, right? Without finding the root cause basis on data, right? And continuous improvement. That means you have to create the approach that if you find anything, that you have to find out the root of improvement also. It is a proof adaptable to diverse the business environment. If you work in this process, your business will improve. Your quality of product, quality of service, customer satisfaction will improve, right?
Hmm.
Now, industry applications. So now what is that? The certification and training, what all certification and training is being done by, so ideally it is being done by the lots of organizations are there, but there is ask and IASSC. These are the organization who is working as a regulatory for that, right? Now, impact and legacy of the Six Sigma training. So, Six Sigma impact extends the beyond quality improvement and it has influenced broader business practices in the market, right? Now, everybody talks about the Six Sigma.
Hmm.
Anybody associated with any good or big organization, they know what is Six Sigma, right? So, fostering a culture of continuous improvement and data-driven decision making and customer centricity, many companies continue to leverage Six Sigma principles to enhance their competitiveness business, right, in the market, reduce the cost, that means increase the revenue, and achieve sustainability, right? So, for everything, you will have to do that data-driven approach. So ideally, we say the Six Sigma emerged from a blend of statistical quality control principle to pioneering efforts of Motorola and widespread adoption by companies like GE, and then it is followed by the all big organization now. And it continues to evolve and shape modern business practices as a powerful methodology for achieving operational excellence and driving continuous improvement, right? This is how it is going
Hmm.
to work. Now we'll understand the roles and responsibilities and the level of Six Sigma. What is the level of Six Sigma? So first of all, we understand the level of Six Sigma. We say we have champions. So champions are what? Senior executives who sponsor the Six Sigma project and ensure alignment with organizational goal.